Let me know if my screen is visible. Right? Type yes in the chat box. Hope you're able to see my screen. Okay, Ganesh. Okay, yesterday we were discussing about the int data type, integer, specifically under integer categories. We have four data types. One is byte, short, int, and long. Right. So we just started discussing about the byte data type. Right. So these are the four points that one should remember when you talk about the byte data type. Right. When you say byte, you talk about size. Right. Any data type. When you talk about any data type, you talk about size, you talk about its default value, you talk about whether it is assigned or unsigned, you talk about its ranges. So these are the points that you will like introduce on top of each and every data type. Okay. So we have seen some problems on the byte data type. Okay. Today you will understand why it is called as a signed data type. And after discussing that, we'll also understand why the range is perfectly in between 128 to minus 128 to plus 127. And we will do some problems on top of this. Right. So let me open a new Byte screen. The byte data type. So since it is a case sensitive, let us get used to the case itself. The byte means it should be starting with a lower case. The byte data type. Okay. So the 4 points that we have discussed yesterday is not only byte data type. You talk data type. You have to talk about its size. So let me keep it very simple. One byte. One byte is the collection of 8 bits. Secondly, you talk about its signature. So it is a signed data type. Why it is signed data type? We will discuss that. And thirdly, its default value should come into picture. The default value is something like when you're not assigning any value by using the byte data type, the Java is going to generate a default value. So in this case, the default value for byte is 0. I'm giving it very simple. And the fourth point is the range. The range of values that the byte can accommodate. So when I talk about range, the range is fixed for the byte data type, which is minus 128 to plus 127. Right. So now we will just understand why it is called as a signed data type. So before understanding the signed data type concept, I have already said that when you say byte is going to accommodate. When we can also call it as its size is 1 byte. So 1 byte is also called as the collection of 8 bits. So this is how it can be represented from the memory perspective. 8 bits, right? This is how the 8 bits looks like, right? So when I do this, right, I am trying to differentiate the negative numbers and the positive numbers. So when I say signed data type, you must understand that the leftmost bit is reserved for the signature. The leftmost bit is reserved for the signature. Right. So again, we as developers, we as human beings, we can able to differentiate a number just by looking at it, isn't it? Very simple. When you look at a number, by looking at the number, we can able to say whether it is a positive number or negative number. Right? Because we are, we have understood that in such a way that by looking at the number, we can able to identify whether it is a positive or negative number. Right? So if I say -2, we know it is a negative number. If I say 2, or if I say +2, we know that it is a positive number. By looking at it, we can say that. But how the system, how the memory, internally, how the memory is going to understand this, how these differentiations is getting happened inside, right? So this MSP, this part, this leftmost bit is going to take care of that, right? When you say, if you find that leftmost bit is 1, then it means that this particular bit is representing a negative number, negative signature. When you find the leftmost bit as 0, it means that the particular the particular block of memory or this particular collection of bits is going to represent a positive number. Very simple. If you find 1, it is a negative number. If you find 0, it is a positive number. Right? So if you say that I have like it is the range is categorized from minus 128 to plus 127. What does it really mean? Right? So since it is a signed bit, this is so we need to differentiate. Signed means negative numbers will also be included to specify or to store values. If I don't say signed, if I say unsigned, for example, instead of signed, if I say unsigned number, right, the range will always start from 0 to what? 0 to some value. If it is unsigned number, the range is going to start from 0. But if it is a signed number, the range is going to start from a negative number. We cannot say what negative number it is going to be without performing some calculations, but we should understand that we are going to consider the negative values as well as the positive values. That is what the signed data type means. As simple as that. Right? So let us conclude this. So the theory says the byte data type is going to accommodate values ranging from minus 28 to plus 127. What does it mean? So if you consider this, if I do zeros, and if I keep ones everywhere, right? So this particular block of memory, this particular collection of bits is representing a number. The number is nothing but minus 128. Conversion, just convert it. First bit, assign this first bit is also equal to what? Let me give the place values. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, and 2 to the power of 7. So 2 to the power of 7 is equal to 128. I have already said if you find 1, it is talking about the signature. So just put minus here. So this is the least value that is occupied by a byte data type, right? So when I say byte data type internally has a storage capacity of 1 byte. So 1 byte is also called as 8 bits. Right? So least value can be minus 128. This is the least value that it can accommodate. That's why it is minus 1. It is starting from minus 20. So highest value, when you talk about highest value, and again first bit, the leftmost bit is going to get reserved for the what? For the signature. So in this case, plus. Right? So just give its place values 2 to the power of 0, 2 to the power of 1, 2 upon 2, 2, 3, 2 to the power of 4, 5, and 6. Just do the substitution, direct substitution. 2 to the power of 6 is equal to what? 64 plus 2 to the power of 32 plus 2 to the power of 4 is what? 16 plus 2 to the power of 3 is 8 plus 4 plus 2 plus 1. If you do this, if you evaluate this, you will be getting what? 127. So this is the maximum value that the byte data type is going to occupy, and this is a minimum value. Hope it is making sense. Right? Very simple. Just try to allocate the blocks. Right? In this case, 8 blocks. Right? First, reserve the first leftmost bit for the signature. Reserve the leftmost bit for the signature. Right? And you can give the values according to the, if it is a negative number, literally you can do 2's complement. If it is a positive number, literally you can just directly write the number. So what does it mean? For example, if I want to store byte A equal to 5, positive number, right? So how this positive number can be represented? Very simple. Directly convert this decimal number to the binary number. We know the conversion. We use 5, 2 2's 4, balance 1, 2 1's 2, balance 0. Right? So the last 3 numbers are going to be what? Last 3 bits are going to be 1 0 1. Right? So byte is a combination of 8 bits, collection of 8 bits. So the remaining bits has to be stored with 0. remaining 5 bits in this case. So this is how the value 5 will be stored in the database. Right? If you convert this directly, just try to put the place values for the ones bit, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. So we are going to include only 2 to the power of 0 because we are going to consider only the ones bit. So in this case 4 plus this is going to give us 1 equal to 5. Right? So this is how the positive value is getting stored. And again, if you talk about the negative value, for the negative value byte a equal to -5, first you find the positive value. This is how the positive 5 is going to be, right? 0, 0, 0, 0, 0, and 0. After finding the positive value, do the ones complement. You know, ones complement is nothing but what? Toggling the bits. If it is 0, do 1. I mean, just replace the 0 with 1. 1, 1, 1, 1, 0, 1, 0. After doing ones complement, we have to find the twos complement. And again, twos complement is what? Adding 1 to the ones complement. As simple as that. Just add a 1 to the ones complement. You get twos complement. So the number is going to be what? 1, 1, 1, 1, 1, 0, 1, 1. So this is the number we got. Convert this number to equivalent decimal number, you will get -5. Let us do this. 1, 1, 1, 1, 1, 0, 1, 1. Right? Right? The first most bit is it represents the negative value. So in this case, -128 plus 54 plus 32 plus 16 plus 8 plus, we will not consider this. We will ignore 4 plus 2 plus 1. After doing this evaluation, so 64, 32, 96, 112, 120, 123. We get what? -1. Making sense? Right. Now the question is, what happens? Now we will see some problems. Let us take the same example, T example. Right. So I am trying to assign byte T equal to 127. System dot out dot println. Very simple program. I am taking a value. I have a value 127. I want to store that value. So in this case, I am using the byte data type. So this is my own user defined variable. Can be anything, assuming it as T. So the cost of the T is not going to be 127. So let us take any other thing here. Let me take it as ticket. Ticket. I want to print this ticket. So compilation. I am doing the compilation. So let me open the command prompt. After opening the command prompt, I need to choose the exact path where this .java file has been stored. So this is the place I am going to store this t.java file. So same location I am pointing it here. The D drive, Java C is a folder. Inside this Java 3 folder, I have the file. Which file? T.java file is. Now what I am trying to do, I am trying to do the compilation. For the compilation, the command is java c space t.java. Right? So compilation is successful. So we get 127, no issues. Very straightforward. So we have assigned a data type and we get what? We are trying to access the same value, ticket. Now the question is, what if I do 128? Right? The question is, I am trying to assign a value 128. If you see, this 128 is something. If you convert this into the binary number, this 128 value is something that is actually out of the range of this byte data type. So when you look at this byte data type, what usually we will see. So the maximum positive value that you can store in the byte data type is 127, but I am deliberately trying to store a value which is out of range, 128 here I'm storing, right? So internally, so let me execute the same program. Let me do the compilation. The Java C space t dot Java. See what it says. We are getting an error. Incompatible type, possibly lossy conversion from integer to byte. It is saying something. Compiler is not happy with our code. It is saying something. It is saying that, hey man, you're doing some mistake. So what mistake we are doing? It has said in the line number 9 there is an error in the line number 9. So the error is what? Incompatible types, possibly lossy conversion from integer to byte. Something we are not sure what is this. What is this lossy conversion into byte? So this is something compiler is trying to like inform the developer. Some error is there in the line number 9. So when you go back to the line number 9, right? So I think this is the line number 9. So the error is here. Right? Why that error is being thrown is, now let us analyze this from the memory perspective for the better understanding. So let me go back here. Let me take the same program. This is the program, right? If I want to think as a beginner, like I need to save this program with .java extension. We know that already. After this compiler come into picture, right? Now it is not getting into the JVM because the compiler, as soon as we compile this, compiler is not happy with our code, and it has just thrown some error. So this is what the error it is throwing us, right? So compiler is not happy with our code, and after compilation, the execution is not happening because compiler has found some error in our code. This is the error, possible lossy conversion. Right? Exactly at the line number 9. This is the line number 9. There are some spaces here. That's why literally you don't say this as line number 9. See, there are some spaces here, empty spaces, empty lines here. So considering that, it is line number 9. If you count these empty spaces, so this is exactly the line number 9. So we are saying byte ticket 128. So we are assigning a positive value to the byte data type with the variable name ticket. So internally, as soon as the compiler encounters this byte data type, it will allocate some memory. Right? For the byte data type, it is a collection of 8 bits. So maximum it will allocate 8 bits of memory. One more space is missing. This is how it gets allocated. 8 bits of memory. And the name of the memory location is what? Ticket. Because that is what we have given, isn't it? Ticket. Right? Now what happens internally? This decimal number 128 needs to get converted to the equivalent binary number. Isn't it? So let us do the conversion. 128. 128 is a positive number. It means the first the first leftmost bit we have to add 0. I mean 0 will be added internally because 128 is a positive number. I already said that it's a positive number. The leftmost bit will be used to represent the symbol. The 0 is representing the positive symbol. So 0 will be added here. Right? Now we will calculate the equivalent binary number for 128. So 232s 0 0 216s 0 28s 0 24s 0 22s 0 and the last one is 21s 0. If I extract this from bottom to top, we get what? 1 7 zeros and 1. So this is what we got, right? Just try to allow the same values here. 7 zeros and 1. So we have spaces for 1 2 3 4 5 6 7 zeros. We don't have a space to accommodate for accommodate this one number. We don't have space, any space for this one number. We cannot use this space because this particular space is reserved for the signature, positive signature. So we don't have any accommodation for this. Means the values that we are trying to save is getting overflowed. There is no space to accommodate this value, right? So if you take specifically 127 instead of 128, if you take specifically 127, right, there is an option to store this 127, right? All the memory spaces will be what we can replace all these memory spaces with the equivalent binary equivalent of 127 number. But when you take 128, one number is getting overflowed. Right? That's the reason why we are getting this error. Right? So logic conversion is nothing but, so it says logic conversion from integer to byte. It is expecting us to assign this particular number with a bigger data type. By default, the bigger data type, the system is going to consider integer as the bigger data type or the default data type. It is indirectly saying us, hey, you are choosing to store a number, right? That is where byte data type is not capable enough or not as sufficient space enough to store this number. So go for int. It is just saying us to go for int. Hope making sense. So if I want to eliminate this error, the simple way for me is just follow the compiler's instructions. Compiler is saying possible logic conversion from int to type. It is asking us to say that instead of byte use int. I will execute this program. So let us listen to the compiler this time. Let us listen to the compiler. I am just making changes byte to int. I have just saved this, right? Compilation again. Execution 128. This time no error. Right? Now the idea here is very simple, right? So the idea here is not about changing the data type from byte to int. The idea is about understanding, right, the capacity, the maximum range that the byte data type can occupy. If you are violating this maximum range, right, we get error. What kind of error we are going to get? We are going to get an error like possible lossy conversion. Possible lossy conversion is nothing but compiler is indirectly telling the developer you are trying to violate the range values, right? Byte data type is meant to accommodate values from -127 to +120, -128 to +127. But in this case, you are violating the condition. So that's why I am giving out this error. If we still want to execute, try to convert the byte data type in data type. As simple as that. Right? So these things are like these things looks very 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 simple for the visibility, but you may encounter a lot of trouble when you are trying to develop a real application. So while developing a real applications, if you have any values, it's your responsibility to ensure that the values are getting stored by using the right data type. Making sense? Now we will see some problems here. Right? Now we will have to answer for these problems. Right? Now let me take byte instead of ticket. Let us take a the nominal values. Let byte a equal to 10. I am taking a byte b equal to 20. So two data types. Same data types. I have taken different identifiers and different values. Right? So I am trying to fetch. I am trying to evaluate what I am trying to perform the addition operation, right, for these two datas. One is 10, second one is 20. Right? For that, I am just using these identifiers, and I am using an operator, plus operator, right? So what could be the possible answer? Anyone with the eyes can say that the answer is going to be 30. Yes or no? You understand my question? Right? What answer I am going to get? Possibly the answer is going to be 30. Right? Tell me what answer I am going to get. 30 or will I get any error? I am expecting answers from you. Yes, 30. Very obvious. It is 30. Yes, correct. Right? Now let us understand this. Now you tell me, I am trying to do this. I mean, I'm trying to get the answer in other way, right? My expectation is very simple. I want to add two numbers, right? So what the answer I would be expecting in this case? This is one of the popular interview question. Very, very famous interview question, right? You don't get these things in the internet. Now, what answer? What is the possible answer? I mean, what is the anticipated answer? Logically, what could be the anticipated answer? I mean, for this, can anyone answer what could be the? See, very simple, guys. You don't think much. Just think like a mathematical student, right? In your maths, when I say a equal to 10, b equal to 10. Think mathematically. B equal to 20. Right? Can I say a plus b equal to 30? Right? Or instead of doing this, I can also say like, if I say c equal to a plus b, what is the answer for c now? 30, isn't it? Right? Answer is 30. Right? Like this. But if you choose Java to represent the same logic, if we try to substitute the same logic by using the Java programming language, right? So visibly, logically, the answer should be 30. Correct? Yes or no? Yes or no? Okay. Everyone are saying 30, 30, 30. Okay, good. That's good. I am getting some answers from your side. So internally, what is happening is very simple. I have a data type byte. So firstly, I am assigning 10 to the identifier A, 20 to the identifier B, and in this line, if you observe this line, right? I am doing what? So I want to do this. I want to assign C equal to 30, but I am ensuring that the C is dependent on this previous two values. Instead of doing this, I am doing this A plus B. Both are same. Let us say that if I am doing this, I'm saving and I'm trying to run Java C space t dot Java space t. Answer is 30 because the value of C is directly what value has been assigned to C, which is 30. So output is, it is very obvious that output is 30. But when you do this, we think that the output is going to be 30, but something is going to happen internally. See, we get error. This is the most popular interview question. I will tell you why we are getting error in this case. You might be wondering that just now we have said that byte is going to accommodate values from minus 28 to plus 127. Valid question. That is what I said. I said byte can accommodate values from minus 128 to plus 127. Earlier, previously, right, I did a small change. What did I do? I have just assigned a value that is out of the range, which is 128, out of the range. So it is obvious that I will be getting this error, possibly logic conversion. But in this case, I am also getting the same error when I try to calculate a value combination of 2 bytes. I am also getting the same. Why I am getting the same error? Because if I add this 2, the answer is going to be 30. 30 is within the range. But still I am getting the error, which is saying that it is possibly logic conversion. The error is similar to the previous error. Previous error is something like we got that error because of the violation. It's same error we are getting here. The question is why. So this was one of the interview questions, not one of the interview questions, most frequently asked interview questions in the interview room. What could be the output? Blindly we will choose what? We will choose the answer is 30, but we are getting the output is compiler is not happy with our code. It is showing us some. Why it is showing us an error? We will see that. Okay. So what is happening internally is so this is the code, right? After compilation, a compiler will check if there are any errors in the code. So it is happy with this first line, no issues. It is also happy with the second line, no issues. But when it tries to see this third line, C equal to A plus B, right? So here we are doing some evaluation by using a plus operator. Try to focus here. We started using an operator, plus operator, right? Basically in Java, when you use a plus operator, it also ensure that, right? So by using plus operator, we will be usually having two operands. Anything left hand side can be a number and the right hand side can also be a number, right? But Java will expect only one thing. By default, Java is going to accept you can use any number the left hand side or in the right hand side. Use a number, no problem for me, but try to make sure that these two numbers are stored in the integer data type. Only if you do that, I will accept, right? But we did the opposite way, right? We are trying to evaluate an addition operation, right, by choosing two values, right? In our case, our two values are what? One value is 10, second value is 20, isn't it? So this is representing A, this is representing B, right? But whenever you're using an addition whenever you are trying to perform any mathematical operation, not only addition, even it can be subtraction, it can be multiplication, it can be division, anything. Whenever you are performing mathematical operation, I will do the mathematical operation only if the data types are integer. Integer or bigger data type. The minimum data type should be integer. Minimum data type should be integer. If not, I am not going to proceed with this. That's why we are getting this. So by default, if you want to perform any mathematical operation, right, it's our duty to ensure that we are assigning these values to the data type which is integer data type, not any other data type like byte short. Making sense? Right? Okay, sir. If that is the case, if this is the case, can I do like this? So I am saying byte c equal to a plus b. Okay, it is giving us an error because internally Java will accept to perform any mathematical calculations only if the two identifiers are assigned to the integer data type. But we have assigned it to the byte data type, so it is not happening. Instead of doing this, what if I do this? What if I do a plus b? So this is the follow-up question that you may encounter in the interview. What could be the answer for this? Please tell me. I'm just putting this in the chat box. Please, I want answers from you. What could be the possible answer for this? Error or an error, or we get an answer. Compile time error or any answer we get. Tell me. Hello. Hope my question is visible in the chat box. Okay. 30. Okay, Ganesh is saying 30. What about others? 30. Answer. Okay, answer is okay, 30. Good. So this time, yes, you are correct. This time answer is 30. But you should be getting some question somewhere the back of your head, because just now I have said, right? I have just said something. If you want to add two things, right? If these two things belongs to the byte data type, right? We are doing plus operation, right? The compiler will not accept this kind of operation, because compiler will accept you perform any mathematical operations. It is going to accept what? The integer data type. Minimum, it is going to accept integer data type. Right? But in this case, as you said, we will not get any error, because it is just like even though you give A, even though you give B, directly if you are giving it in the system.out.println statement, right? It will convert these values. It is going to convert these values to the integer data type. What does it mean? Very simple. To understand this, so let me say system.out.println A. Now focus here, right? So we get the value as 10 output. very simple. I am assigning a equal to 10 and it is of byte type. So output is going to be 10. Very simple. Right? Before even displaying the output as 10, right, internally some more convention will happen that I am going to introduce. Right? Let me take the new space. Class 40. So focus here. These two questions are very important in the interview room. So this is the question, right? So the answer is obviously 10. But before even printing the answer as 10, what internally so many things will happen. So we know this design already. Byte for the byte. This is what happens for the byte. So 8 bits of memory will be allocated. Let me keep this really simple. If 10 is converted to byte 0, 2, so 10 can be represented like this, right? So when this particular value is placed in system.out.println statement, right? System.out.println statement. If this particular value is getting accessed in the system.out.println statement, right? Now these 8 bits of data type, 8 bits, right? It will not be 8 bits. Internally, the system.out.println is going to allocate a memory which is of 32 bits. By default, 32 bits will be allocated. So 32 bits is a combination of 4 into 4 bytes into 8 bits. Internally, 32 bits will be allocated, right? And 32 bits is nothing but what? It is allocating memory for integer data type. Don't get confused. This is what we have allocated. We are saying byte a equal to 10, right? When this value is getting accessed from the system.out.println, the system memory, this particular system.out.println will ensure that this byte data type is getting converted to the integer data type. Right? So if it is getting converted to the integer data type, it's the same thing, right? Everywhere zeros, and zeros, 1010. So this particular system.out.println will store this particular decimal number in the form of integer data type. So internally byte is getting converted to integer data type. This is one observation that you should understand, right? Very simple. The system.out.println is going to, it can expect any number, but by default it will consider what? It will consider integer data type. So internally this particular a will be stored like this, larger data type. Okay, the same concept. If I take the same example and if I do byte b equal to 20, a plus b, answer is 30, because 10, 20 we will get 30, and this 30 internally will be converted into the integer data type, and the value will be displayed in the console. So this is also a valid one. 30. But my question here is, the question you could encounter is, if I do like this, byte c equal to a plus b, right? If I try to print c here, right? Now we are saying that internally the system.out.println will convert it to integer data type. But I am specifically saying that I am specifically using c. C is nothing but c is what? C is the byte data type. C is the byte data type. Right? It is expecting integer data type. But we are defining what? We have defined it as a byte data type. That's why collision. That's why the collision is happening inside. If I run this, we will get an error. Incomparable as possible logic conversion. The conclusion is very simple. This statement always converts the number into the int data type. But we are saying that we are restricting the conversion. How we are restricting the conversion? We are saying that we are just trying to print the value of C. C is an identifier, right? When you see the C is assigned to a data type by data type. So we are restricting the conversion. Right? When you do that restriction, it is going to throw this error. And how to avoid getting this error? Very simple. Instead of doing this, if you add directly A plus B, right? If you add directly, then you can be asking me one more question, sir. Even the A is the part of byte, B is the also part of the byte, right? And again, when the plus operation is involved directly inside, when you use the plus operator, but previously we haven't used the plus operator. Plus operator was used outside. Right? Whenever you are using the plus operator, this plus operator will expect the data type as integer data type. Right? Not only plus, any mathematical operator if you use, right? When you use any mathematical operator, this mathematical operator will accept the data type as integer data type. It cannot allow any other data type, as simple as that. Right? For this, it has no issues when you do like this. Like, when you try to do the evaluation like this, it has no issues. A plus B, no issues. Right? Internally it will take care. But when you try to perform the same operation by and keep the mathematical operations output to a specific identifier, in this case it is C, right? The moment you use it plus, right, after the evaluation, if the compiler is finding it as a byte instead of int, it's going to throw you there. So the conclusion is very simple. For all the mathematical operations, right, the operator expects the data types to be integer data. If you are using any other data type, data type that is less than integer range, you will get it, right? So why they are pointing towards this question is very simple. Value of first line, value of this is 10. So 10 is falling within the range, 20 is also falling within the range, right? If I do C equal to A plus B, even the output is going to be falling within the range, right? But the compiler is not accepting because internally the design is in such a way that for you trying to perform any mathematical operations between two data types, right, we have to ensure that these two data types needs to be at least the integer data type. So byte is not not the possible not the valid operator, not the valid data type to store the value of addition, to store the value of two addition operands. Right? That's why we are getting this error. Right? So we can conclude one thing here. Right? So when you are trying to assign a byte data type to the value, you can just perform the assignation. That's it. You cannot do any kind of mathematical operations directly. Right? Now we will see some scenarios. Now you answer to me. Scenario 1. Byte, I am saying byte A equal to 100, byte B equal to 50, system.out.println A plus B. What is the answer? Tell me. Now you tell me the answer. Saying byte A equal to 100, byte B equal to 50. A plus B. Samyukta 150, 150, 150. Okay, correct. You understood. Let us test this. 1 minute. Okay, 150. So now the second question is byte A equal to 100, byte B equal to byte A equal to 150. Now tell me what would be the answer, possible answer. Error. The answer is error. Exactly. Why error? We must understand that. See, byte A equal to 150 is something, a kind of violation, isn't it? Don't you think so? The byte can occupy a maximum value of 120 minus 128 plus 127. So 150 is something, it is out of the range. Violation. Right? If I run this, we get error, isn't it? See, possible lossy conversion. Violation. Right? Now this could be valid if I restrict the value that I'm trying to say within the range 127. If I do this, it is valid because 127 is the value that is fitting in the range of byte data type, isn't it? No errors. This is some other thing. This error is some other thing. 1 minute. 177. 127%. It is possible. Okay, what if I do this? Tell me. How? Okay, correct. Okay, this is also correct. Correct. Now you tell me. Now me to copy. Yes, error. Exactly. Why error? Because out of the range. Out of the range. So what if I do this? So now you tell me. Right? C equal to A plus. Now if you are answering this, it means you are good with this subject. I mean, good with this byte data type. Error. Why error? Yes, exactly error. We got to know why we are getting error because so this explanation, let me repeat this explanation, right? So this is a popular interview question, very famous interview question, right? It is not like, see, whenever you're trying to perform any mathematical operations by the combination of two byte data types, right? You cannot perform any mathematical operation. Why we cannot any perform mathematical operation? Because internally this operators like plus, minus, into, or division, any mathematical operation, it will expect the operands in the sense it will expect this identifiers to be of integer data type. Minimum it will expect integer data type. Minimum, right? It will not expect byte data type or short data type. As simple as that, right? So to get this done, I have an option, right? Instead of doing like this, again, if I remove this, now what will be the answer now? Now tell me what will be the answer? 0. Exactly. This is possible. Internally, system.out.println is going to convert this to integer data type. Then it will perform the evaluation. Right? This will take care of this particular system.out.println statement will take care of doing the conversion. Right? It will convert a value to the integer data type. It will convert b value to the integer data type. After conversion, it is performing operation. So both are really different, completely different. Right? We may end up in confusion when the interviewer is asking questions like this. He would say, if this is giving answer, why it is not giving answer? Then we should be capable enough to tell the interviewer that the mathematical operation, if you want to do any mathematical operation on two operands that is specified on top of byte data type, right? It is not possible because internally it is designed in such a way that this mathematical operations can be performed on the top of integer operator minimum. Byte operator is not eligible for the mathematical operations, as simple as that, right? The second question can be, how do I achieve this? How you could achieve this? I want to do the mathematical operation by using, I don't want to change the values of this particular data type, right? To do that, do it directly. Do it directly. We can achieve this. If I do this, if I try to execute this, zero. We got the output. Right. So these are the possible scenarios, possible cases, where you might be encountering this kind of interview questions. Not only for the pressure level, these questions are common for the candidates who have experienced more than 3 to 4 years. Basic fundamentals, right? So we have just completed about the byte data type, right? So when you talk about byte data type, you talk about 4 things. Not only byte data type, you talk about any data type, you talk about 4 things. What are the 4 things? First is its default value, right? And its size you talk about, and then its range you talk about, right? And whether it is a signed or unsigned. Right? So it is said, Java has said that internally Java is saying that this byte data type is a signed data type, means you are eligible to store negative numbers as well. How that is possible? We have seen those things in the previous classes about this bit manipulations. Right? Making sense? Any doubts on this? Please feel free to ask any doubts. Right? Any doubts? Ashwant, Samyukta, Darshini. Okay, now we will do a small program here, right? And if you ever want to develop a calculator application, your requirement is, right? If your interviewer is telling you, can you develop a calculator application? My calculator application should perform addition operation as well as the subtraction operation. Only 2 operations my calculator application should perform, right? In those cases, it is highly recommended to not to choose this byte data type or short data type. Right? We will discuss about this integer data type in tomorrow's class, but it would be really appropriate when you go with this integer data type. Right? If I have 2 values, we will pass these values we will take these values from the end user. I will tell you how to do that. For the time being, a plus b a minus b. A simple calculator. You give me 2 numbers, I will perform addition, subtraction, multiplication, and division. A divided 3. And again, the question could be what? These values are hard coded, means this value should be defined in the program itself. But my requirement is I need to get this as the inputs from the end user. The end user, right? He should be able to type 2 values, and the output should be the addition of 2 numbers, subtraction of these 2 numbers, multiplication, division. This is the generic example. Tomorrow we will see how this can be developed by using scanner classes. All the things we got. So it is not possible with byte operator. That's my intention. These things are not possible with what? It is possible with byte operators, but since we are using system.out.println, it is possible. But if you are trying to do this evaluation outside the system.out.println, it's not possible. Let us check that. I don't believe without same thing is possible, but byte has some restrictions. You cannot take any number that is behind 127. So that's why we always it's always recommended to choose integer data type, and we will discuss about this integer, short, and the remaining data types in the tomorrow's classes. Tomorrow classes, the remaining data types is going to be very easy to understand. Okay, these are the restrictions that are applied only for the byte data type. That is the takeaway. Right. So the conclusion is, in the today's class, what we have learned so far in the today's class, right? This is not possible. A plus B is not possible with byte. When I say A plus B is not possible in the byte, it means if I assign a value byte A equal to 100, byte B equal to 100, we cannot do this. Okay? We cannot do this. Byte C equal to A plus B, we cannot do this outside the system.out. But the same thing can be achieved inside the system.out.println. A plus B. This is possible. Why it is not achieved? Because this plus operator is an operator. Plus is an operator, mathematical operator, or it performs some operation, addition operation, right? In the left, it will always expect an integer, at least an integer, in its left side and as well as in the right side. If it is anything apart from this integer, it will not accept. Below the integer, right? If I say below the integer, it means byte dot integer and long. This is accepted again. Only the values below only the data types that is falling behind the integer. Means these are the smaller data types, byte, short, or smaller data types compared to integer data type. So these two data types are not accepted. Tomorrow we will see some more problems on short data type before proceeding with integer data type. After getting into long data type, the concept will be crystal clear. Right? Try to do the notes. Don't do the running notes. If you have time, try to repeat this video and try to develop or write your own notes. I will also sharing my notes as well, but try to write your own notes. Okay? That's all for the day. I hope we are good to go.